These are the solutions to the quiz at the end of lesson 8.1. Now, number 1, Galileo attempts to measure the speed of light. Now we know that speed is always distance over time for a constant speed, so time is going to be distance over speed. Distance 1,500 meters, speed 3 by 10 to the 8 gives us 5 by 10 to the minus 6 seconds, or 5 microseconds, so that is C. Now number 2 is D, because some objects give out light, they are luminous, but some just scatter it. 3, if we have a look at the options, A and B actually have reflection in them. C says no light is refracted, which means that all of it must have been reflected. D, not all refracted, means that some must have been reflected, so E is the only possibility there. And number 4, that is A, because only A involves white light spreading into its different wavelengths.
Now, this is the corrected version of the solution to question 5, because the first one I did not only was unnecessarily complicated, but also gave the wrong answer. So I'm just going to go through how it should have been done. Now, we've got a pulse that is 2.7 by 10 to the minus 11 seconds long. And we're told that the frequency of the light is 5.1 by 10 to the 14 hertz. Now, we simply need to work out that that means that the length of time of one wavelength, in other words, the period, which is 1 over the frequency, is 1.96 by 10 to the minus 15 seconds. So that means that the number of them that will fit into a duration of 2.7 by 10 to the minus 11 seconds is actually 2.7 by 10 to the minus 11 divided by the time for 1, which is 1.96 by 10 to the minus 15, and that turns out to be approximately 13,800 pulses fit into that duration of time. Now, for part B, we're told that the light slows from 3 by 10 to the 8 meters per second to 2.3 by 10 to the 8, and so the refractive index is just the vacuum speed over the medium speed, which turns out to be 1.3. And then for part C, the frequency, they tell you, remains the same, so that means that the period is the same, and so the number of wavelengths that fit into that length of time for the pulse is going to be the same as in A, which is about 13,800.
Now number 6, sine of the critical angle is N2 over N1, 1 over 1.8, which is 0.555, so the critical angle is 33.75 degrees. And remember, we don't turn it into minutes and seconds because we want everything to be a decimal. Now number 7, let's start with the red light. Sine of the refracted angle for red is N1 over the refractive index for red times sine theta 1, which is 1 times sine 45 over 1.520. So the angle for red is 27.7233 degrees. Violet, we have the sine theta for violet is 1 times sine 45 over 1.538. So that means the angle for violet is 27.3714 degrees. I've kept so many decimal places so that I can then subtract them. Going to be 0.35 degrees.